Yo.
So one morning when I woke up, I had a dream that like I was laying in bed Snapchatting people, and like the time was early enough, so I was like, hey, I'll just like lay here a little bit, and then I woke up. It was a dream.
Really?
And I was like 30 minutes late. So yeah, my brain played tricks on me.
It does. It does. And it's okay that your brain plays tricks on you.
I was like this week, I think.
All right, these are the first. Heck, you might be dreaming right now. We're all a part of your dream.
I'm scared.
All right, these are the first three problems from our homework. So, problem 1 and 2, they have the exact same radical that you're dealing with when you are adding or subtracting. So the nice thing about that is you treat the radical as like an x. So this is basically the same type of operation as this, where if you were to add these together, you'd get 4x. But, obviously those aren't x's, but these radicals will come together and give me an answer of 4 square root 5, where you notice the radical doesn't change size. So the operation of a square root property underneath the square root does not work with addition or subtraction. It's too high of a property to do it. So problem number 2, it's a subtraction problem. You do the exact same radicals. So you're going to subtract those, and the square root of 3 stays as is. But then when you get to number 3, things start not working the same way. Why would I say that? Yeah, I have root 20 and root 45. They're not the same radical, so we have to go through and apply ourselves to say, could I take 4 root 20? So let's think about what 4 root 20 is. Could I break that down to 2 times 10? And 10 would be 2 times 5. Would that be okay? Because 2 times 2 is 4 times 5 is 20. So then I have that. That comes out. So I get 4 times 2 square root 5. So what does this clean up to? 8 root 5. So this is going to be 8 root 5 right here. Now, we've just cleaned up that one particular radical. Let's look at the other one, 2 root 45. And so doing the same idea, how would I approach root 45? Before I said, well, 2 goes into 20 10 times and broke down, but I can't go 2 into 45, can I? So what's the next number that would go into 45? 3. Okay, and 3 times 15, you're right saying 5 times 9, but I was just trying to go with the basic thing. So 3 times 15 is 45, and then 15 breaks it 3 times 5. So 3 times 3 is 9, 9 times 5 is 45. So what does this one clean up to? 2 times 3 root 5, which becomes 6 root 5. Now, does this one appear to be like those?
Yes.
Yeah, so what is this going to break up to? 14 root 5. So there's ways that you can go through and you can manipulate it to where it's going to break down and start working. And again, guys and girls, we're not hitting our calculator button saying, sweet, there's a square root button on my calculator, so it works. We're breaking it down without using our calculators. Before I go further, I think some of you, maybe not all of you, have you started getting your registration stuff for next year?
Yeah.
Okay, so today I can sign off on it, and then if later you get it. So just to kind of give you a heads up, CP Algebra 1, which is this class. The next class really is CP Geometry, okay, which is a great class. This leap here going to CP Accelerated Geometry really isn't for any of you, and this is why. This class here, this class here, to leap to here, you're looking at a 10 to 15% drop in your grade. Okay, this class here, what we're in here, is not preparing you for this. So a 10 to 15% drop in your grade, I mean, you're talking about a letter grade to a letter grade and a half. Could even be 2 letter grades, depending if you're at like a 91%. That means you can drop all the way to a C. Okay, and I don't think we want to do that. This here, this is anywhere from 1 to 5% drop in grade, which is just normal attrition of a class. Okay, so for most of you, I will sign off on this. Okay. None of you earned an F in here first semester, so I don't have to sign any of you up to repeat it. Yeah.
Isn't there something called like just geometry? That's what my counselor said.
That there is one class that's lower than this. It's the C that this does not feed into. So a kid that came in not having the math skills for this class, we have that class for it. We actually don't even have it in our catalog, but the next progression of this class is CP Geometry. And it's a great class, really is. So those are just a few things. So I do teach the accelerated geometry. I can tell you right now in my accelerated geometry, my average grade between the 2 classes is right around an 80% for class grades. So they're doing well, but I will tell you that I've had a large amount of kids, probably 3 or 4 kids per class, that had to drop down to the CP Geometry early. Okay, so that's just some things to think about. So I'll be signing off.
Are you teaching CP Geometry next year?
This is how I know what I'm teaching. Mr. Dwyer, who's the math coordinator, will ask me, "Hey, what do you want to teach next year?" And I always say, "Just fill everyone else's schedules first. Whatever you have left, I'm happy to teach." But I've always done that with math. I don't ever claim an ownership to a class. I'm happy to teach what's ever left over. There are some teachers that are like, "Oh my gosh, this is my favorite class. This is what I have to teach," and they're insistent upon it, which is great. But I know that it makes it a lot easier in the world of scheduling, saying, "Hey, we have this many of this type of class." So what we try and do here, and for here on out, we will try and make sure each teacher only has 2 different classes that they teach. So they'll have 3 of one and 2 of another, or 4 and 1. But most likely it'll be 2 and 3. But we'll figure it out. And me, I'm only teach 3 math classes, and then I have my other part of my job. Would you guys quit? So I don't know what I'm teaching next year. I'll let you know once our registration's done and we know what our numbers are, and we'll know to say, all right, I guess I'll teach this or that. Would I like to have you in class again? Absolutely.
Absolutely, yes.
I don't know why you wouldn't want to have me as a teacher.
I want you again. You should
recommend you?
Yeah.
Sure.
That one.
That would be the first thing I would fill out.
You should recommend me.
I need to have Stephen back in class. Whatever it takes, no matter what, I need to have him in class.
Even if it's
Even if it's underwater, blowing bubbles. All right. So, hey, can I break that down a little bit?
Yes.
18 breaks down to 2 times 9, which is 233.
Yeah.
Is that right? Did I do that right?
Yep.
What about 50? Does that break down?
Yep. To 255.
255, right? Do you agree?
Yep.
And notice I'm using the smallest prime numbers to get there. All right, so this cleans up to this, which becomes what? 9 root 2. This cleans up to this, which is? So can I combine these together now?
Yeah.
I have the same radicals. All right, so that's going to give me what? 44 root 2. Well, what about number 5? What does this one break down to? 6 times 6, which is?
3 times 2 times 3.
Is this a perfect square, though? This is a perfect square, so is this result 12? Ooh, where did that just come from?
Wait.
3 times
Square root of 36 is? 6. 6 times 2 is? 12. Oh, okay. So sometimes you might have to see if this is a perfect square. 12 is going to break down. We've done this before. So this is 2 times 2 times 3. Did I do that right?
Yeah.
So I'm going to take those out. So I get 3 times 2 root 3, which I get 12 plus 6 root 3. Can I combine those together?
No.
No,
They're not the same.
not the same. You can.
No, you can't.
One's a radical, one's
Oh
not.
my gosh.
One has a one of all the radicals get undone, the other one doesn't. All right, well, let's try this one. So 80 is going to break down to 2 times 40, right?
Yeah.
40 breaks down to 2 times 20. 20 breaks down to 2 times 10. 10 breaks down to 2 times 5. So is 80 broken down completely? 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 5 is 471, right? No,
Yep.
80.
Oh, darn.
All right, let's break 24 down. 2 times 12. 12 breaks down to 2 times 6. 6 breaks down to 2 times 3. Did I do that right? So let's take a look. That comes out, and that comes out. So outside I have 5 times 2 times 2, square root 5 left. So that's 10, 20 square root 5. Does that make sense how I just did that?
Yeah.
And then this one, I only have a pair right there. So I have minus 4 times 2, and I'm left with root 6. Root 6 won't break down to any perfect squares, correct? So minus 8 root 6. Can I combine these together?
No.
No, I have a root 5 and I have a root 6. They won't add or subtract. Does that make a little bit of sense? Then 7, 8, 9, and 10, we start dealing with raising it to a power, which means we're going to start multiplying them. So let's take a look at what we have here. 7, we have 3 root 7 squared. Number 8, we have 10 root 2 quantity squared. And number 9, we have 3 square root 5, parentheses, root 2 plus 3 root 5. Okay? On this problem, how many 3 root 7s am I multiplying together? So is multiplication a different operation than addition or subtraction? A little bit higher level. So the higher level means we can start getting into stuff. So 3 times 3 is 9, and then root 7 times root 7 is root 49.
That's what I
Which
did
is that?
wrong.
So what does that get me outside?
7 times 9.
7 times 9, which is
63.
63. Hey, where'd the radical go? Well, root 7 times root 7 is root 49. Root 49 is a perfect square, so the square root of 49 is 7. That's where it went. It's gone. Okay? Hey, how many 10 root 2s am I multiplying together? 2. Okay.
10 root 2 times 10 root 2.
There you go. So 10 times 10 is 100. Root 2 times root 2 is root 4. Square root of 4 is no radical because we dealt with a perfect square. Is that okay? Did I do it right? So. And please, guys and girls, I'm not using a calculator because it's not required. You're not smarter than the class going, oh, I found a square root key on my calculator and I know how to use it. No, you don't. You really don't. You're giving me these decimal approximates which are incorrect. That's not what we're looking for.
Would you say it like that?
Huh?
No.
No, you don't. I used to have kids, just show me what buttons to push. Well, every problem's different. This one you hit 7 plus 8. Oh, okay, where's 7? It's next to the 6. Where's 6? The 6 kind of... Wait, mister.
Wait, the 6 is like a 9?
All right, 11 times 15. Where's the 11 at? It's 1, 1. How do you know? I guessed. Sorry, I should be sarcastic.
You
There
know, you
was some...
sound like the dude in the wheelchair in Family Guy. Like when you do that
Joe.
voice guy. Yeah.
Whoa, what the
I'm a
heck?
guy in
Oh,
a wheelchair?
Yeah.
Alright. Back to math. Alright. Alright, hey, how do I do this first one? 3 root 5 times root 2. 3 root what?
That's so real.
3 root what?
3 root 10.
10. I can multiply inside to inside. And then I have a plus sign. Then 3 times 3 is 5. Root 5 times root 5 is root 25. So 10 breaks down to 2 times 5. So will that break down into any perfect squares?
No.
No. So that's just going to stay as 3 root 10. What's the square root of 25? 5. It worked out perfect. So I get 3 root 10 plus 45. Nothing further to do. Number 10. 11, 12. Man, never been called that dude in a wheelchair.
Oh, it was
No,
number 10.
no.
Number 20 was the one that got me.
What did
We
which
called
one?
him a guy in a
this one.
wheelchair.
This one got you?
Yeah.
The police officer. There you go.
My name is Kevin
Okay. Problem number 10. If I multiply this and this together, I'm going to get 4 square root 3. Why didn't I make it root 12? Well, the root 4 wasn't under a radical. Okay? And then if I multiply here and here, that's going to give me minus 2 root 9. Notice under the radicals did.
Wait,
So will
why?
this, huh?
Why?
Root 3 times root 3, root 9. 2 comes along, there's a 1 right there.
Oh, that makes sense.
All right, so 4 root 3 won't break down any further. What does 2 root 9 break down to? 2 times what? 2 times 3. So 4 root 3 minus 6. Done. Number 11. 4-letter math word. Foil. Oh, foil. 1 times 1. 1. 1 times negative root 3. Negative root 3. Root 3 times 1. Positive root 3. Root 3 times negative root 3. Negative root 9. What happens here? They cancel. 1 minus. Those are gone. What's root 9?
Wouldn't that be a plus sign because there's 2 negatives?
These are just add or subtract. Okay. And then positive root 3 times negative root 3 is negative root 9, which is negative 3. So 1 minus 3 is
2.
negative 2.
2.
Careful with those.
I just forgot the negative.
Just forgot the negative. That would be 1 point off a 2-point problem.
Dang.
You'd miss half your points on that.
Dang.
All right.
That would be a 25. No.
All right.
25.
Number 12. Let's break this down. This is one of those where we're looking to group. So 2 times 49 is 9. No, wait. 2 times 49. Is that right? 2 times 49. 49 breaks down to 7 times 7. And then I get 2, 3, 4, 5, and then 1, 2, 3. Okay? Looking for pairs, right? What comes out right there? 7. What comes out here?
2.
That's 2.
X and X, so it's X squared. And what comes out here?
Why is
What do I have left in the numbers? 2. What else?
Two.
X. What else? Y. Okay, clean it up. What is this? 7
X to the second.
squared Y. Good. 2xy. Done.
You forgot the
I might have forgotten something.
No.
I didn't mean to. Can't keep your eyes open? Sorry.
I'm not saying that out loud.
Like,
Glaucoma.
never mind.
Glaucoma.
I can't keep my eyes closed.
Glaucoma. Your eyes are.
You can't keep your eyes closed.
Never mind.
Take off your glasses.
Joe. You're having too much fun.
Where's on?
81. 14. 5 root 21 times 2 root 14. 15. 16y to the 4th over 49x squared. All right, let's take a look. Let's take a look. Is this a perfect square?
Yes.
So that's 12.
And then-
Is this a perfect square?
Yes.
X, 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 and X.
To the
X
third.
to the
X to the third. So everything came out on top. Agree? over, is this
Nine.
perfect square?
Yeah.
9.
What? Oh, that's y.
Y.
Y
Squared.
square root
Square root y.
y.
Wrong. It's not.
Wouldn't it be y squared though, since 2 y's?
Two y's equals one y.
set
Wrong.
y. And then 1 y left.
There you go. Hey, is this answer done?
Yes.
Yes.
You can reduce it.
No, you can reduce it.
Okay.
9 as well.
9, 12. 3 goes into both, so I get 4
Oh.
x to the third
Three.
over 9 y root y. Is this answer done?
No,
Why not?
because you didn't do the bottom.
Do what?
You can reduce to 9.
4 and 9 don't reduce, no.
Oh, no, I don't know.
But no, you
No,
No, no. You didn't reduce the 9 down to 3 when you
To
reduced
three.
it
Oh!
down to 4.
Yeah, that's what I was saying.
Oh,
Yeah.
3.
See, I knew I was
What?
I'm sorry.
I thought you were trying to like mess with us. Like, is this one?
Is
done?
this done now?
Yes.
Yeah.
I think so.
Yeah.
No, it is.
Wait, isn't it like the tug of war thing?
No.
No,
No
because it's
tug of war
the-
because we don't have on top of bottom.
Plus, we don't have
All
a
right idea.
a tug of war.
What do you think? Yeah. Oh yeah. Kenny got it.
Wait, what did he say?
We can't have a square root on the bottom.
Oh.
Do we have a square root on the bottom?
So you gotta
So,
put it down the
I'm gonna
top.
multiply both top and bottom by root y, root y. So move it down. So I get 4x to the third root y, and then root y times root y is what? Y. So what's on bottom?
Y cubed.
3y squared, right? Because this here becomes this. So one of them comes out, multiplies there. So that's our.
That looks like a
Wow,
smiley
good
face.
job.
Did what I could for you.
Okay, now it makes sense.
Is that all right? Oh, so that had a little bit of a gotcha in there. Kenny, good job on that catch. All right.
Good
Let's
job,
see.
Kenny.
We could probably do this one. 5 times 2, that's 10. But you know what I'm going to do? Rather than multiply 21 and 14 together and start breaking it down, I'm going to break 21 down, which is 3 times 7. What do you think? What does 14 break down to? 2 times 7.
Times.
Okay, I have here and here. So that comes out. So I get 10
Times 7.
times 7. What's still left inside?
3 and 2.
3 and 2, which gives me
6.
6. Multiply those.
76.
Done. But can't you break 6 down? No. Because 6 doesn't have a perfect square as part of it. 15. Square root of 16 is 4. Is this perfect square? Y. So what's outside then? Y squared. Good. Is this perfect square?
Yes,
7. Is this perfect square?
yes,
X. Done.
Chill.
All done. All done.
So,
We're not done.
Yeah,
Oh,
no,
I
we
get
have some more.
Just going to do 16, 17, 18. And that should be enough for y'all. You can look it up.
Will we have one more this week?
Yes.
Alright.
I got something special planned.
Cupcakes?
So it's not gonna be
Ice cream?
21.
Oh, I like ice cream.
Oh, yeah.
That was
What
so
happened
funny
with
at the
ice
beginning
cream
of the
every
year.
They actually brought in ice cream.
Yeah, that was
so
that
funny.
was like
joke.
best day ever.
Wasn't that
yeah,
until
bunch of
until
ice cream.
Gentry came?
Till Gentry came. Nah, it wasn't Gentry's fault.
Yes.
I spilled
Yes,
someone's
Abby's.
ice cream.
Still mine.
Oh yeah, that was true.
It was ice cream. Wait, wasn't
That
that?
was
a
Oh,
joke?
I
I don't care. About
Yeah, you were doing a water bottle flip and then you landed on his ice cream and it went over. I think something like that.
That's why I got rid of it.
But notice,
Yeah.
hey, hang on. The important thing is he did not spill his own ice cream.
Okay, yeah.
What kind of
You
ice
spill somebody else's ice cream, it's
You're
not your
okay.
fault. It's
Yeah.
their fault that
cream?
they didn't finish eating it.
It's warm. Vanilla chocolate. I think it was.
I
the
don't
next
know.
one, I don't know.
I mean, there's some people out there like, oh, we'll make this last. Why? Ice cream.
Oh,
Alright.
I used to eat ice cream when I was little.
Here we go.
I actually
What did I get there?
used to eat ice cream.
8. All right, now let's do this. 3 is not going to break down, but 6 breaks down to 3 times 2. To agree? Bless you. And then I have XX and YY. correct?
Yes.
All right, so what comes outside there?
3.
3, so I get 8 times 3.
24.
What comes out here?
Second.
X. What comes out here?
Y.
What's left inside?
24. Oh,
2. All right, so that's 24xy root 2. Cool. This is one of those we can't have a radical on bottom, so what are we going to multiply top and bottom by?
Root 2.
Root 2 and root 2. Root 2 over root 2 is the same thing as 1, so you're not changing the size of the fraction. So 8 times root 2 is 8 root 2. Root 2 times root 2 is root 4. Root 4 is what? 2. What does this reduce to?
2.
4 over 1. So you have the root 2 that comes along for the ride. Done. And number 18, square root of 49, 7. Square root of 36, 6. Done.
Wow, who said that?
I always me. All right.
Just count.
So, ladies and gentlemen, I'm going to give you the remainder of the period to work on the radical review, the first one. I will collect or put a star on top of that. I'll put the points in for you all for that, for being here. If the people aren't here, they have to turn it in. But I would like you to start working on page 21 and 22. 21, 22. Okay? We have a quiz on Tuesday. Okay?
Oh, today's already Friday, huh?
Today is indeed Friday. So let's start on this because we have about 10 minutes. Guys and girls, I would like to sign off on your sheets if you have your sheets. So have those out on your desk. I'll come by and work on it. So
Wait, do we turn? Wait, we don't.
do not turn it in.